Okay, when I say kangaroo, what's the first thing you picture? It's that iconic leap, right? It's this incredible symbol of the Australian outback, a true marvel of motion. But what if everything we think we know about that leap is just scratching the surface?
For most of us, it's just a way to get from point A to point B. But what if it's so much more than that? The source material for this explainer argues that the leap isn't just about movement. It's a complete philosophy of survival, engineered into every single fiber of the animal. This quote just nails it, doesn't it? We're about to break down the kangaroo's leap, not as some simple action, but as the absolute core of its being. It's a solution so elegant that it completely redefines how an animal can master its environment.
And that is the key concept we're digging into today. The leap isn't just an app the kangaroo chooses to run. No, it's the entire operating system. It dictates everything: how muscles are arranged, how the nervous system is wired, and how every drop of energy is managed. So let's start with that wiring. All right, first up, a leap deeper than movement. We're going to look at the neurological default here and challenge the most basic assumption we have, that a kangaroo decides to jump. So the old idea is pretty straightforward. A kangaroo standing still, and then it makes a choice to jump. But the new hypothesis? It flips that completely on its head. Jumping isn't the choice, standing still is the exception. The entire nervous system is fundamentally built to leap.
This is what researchers call the default mode, the baseline state. The kangaroo's nervous system is basically primed to jump 24/7. So standing still isn't its natural resting state, it's an active override. Think of a coiled spring always humming with tension, just waiting to release. That's its normal.
And look, this isn't just some wild guess. There's real evidence. Scientists have found these rhythmic patterns firing in the kangaroo's spinal cord, like you can see here, almost like it's practicing the leap even when it's not moving. And its hind leg muscles, they maintain this state of constant elastic tension, always ready for that next jump.
Section 2. The body as a reimagined machine. Okay, so if the nervous system is the software, what about the hardware? Let's get into the physical design, starting with a part we all think we know, but probably don't: the tail.
We've all been told the tail is for balance, right? Kind of like a tripod leg when it's standing around. And yeah, that's true, but it's such a tiny part of the story. The new hypothesis is way more interesting. The tail is actually a mechanical energy battery. So how does this mechanical battery actually work? It's genius. With every landing, the tail doesn't just steady the body. It absorbs the impact, storing that energy. Then, it redistributes that power over the next few jumps, giving it a little boost and making the whole process more efficient. It's basically a dynamic energy recycling fifth limb. And the reinvention doesn't stop there. Take a look at the skeleton. We tend to think of bones as rigid bricks, just there for support. But in the kangaroo, they're much more like smart, non-linear springs. What that means is they literally change their stiffness depending on the force of the landing. Here's what that looks like in the real world. On a light landing, the bones flex just a little, nice and gentle. But on a huge, hard landing from a massive leap, they don't just snap. They become progressively stiffer as the load increases, spreading that force out. It's how they can handle these immense impacts without shattering. Section 3. Invisible energy and messages. So we've seen the visible hardware. But the true genius of the kangaroo, well, it lies in the invisible systems, the incredible flow of energy and messages that power that leap. This right here is the great paradox of the kangaroo. For almost any other animal, going faster means burning more fuel. Simple. But for a kangaroo, once it hits a certain speed, its energy use actually levels off. It becomes more efficient. I mean, how is that even possible?
Well, the traditional answer has always been about those massive tendons in its legs acting like perfect pogo sticks, storing and releasing elastic energy. And that's definitely a big part of it. But the source material for this explainer suggests a deeper, more radical idea: neural energy recycling.
At slow speeds, the kangaroo's brain is working overtime, making all these constant, tiny, and metabolically expensive adjustments. But as it speeds up, the brain basically hands off control to automated reflex circuits in the spinal cord. The motion becomes rhythmic, automatic. It's like switching from city driving to cruise control on the highway, freeing up the brain and slashing the energy cost. And get this, the leap is a total multitasker. That constant up and down motion, it acts like a built-in fan, pushing air over the body to help it cool down in the Aussie heat. And even the thud of the landing serves a purpose.
Those vibrations travel through the ground, becoming a form of seismic communication to other kangaroos in the area.
Section 4. Lessons for the future. So, what does all this incredible biological engineering actually teach us? Well, the implications go way beyond just biology.
You know, when engineers try to build kangaroo-like robots, they almost always fail. And this table shows you why perfectly. They copy the parts, the springy legs, the big tail, but they can't replicate the reality, which is a deeply integrated system where the nerves, bones, and muscles are all one inseparable unit. You can't just copy one piece and expect it to work. The kangaroo is an indecomposable whole.
And that leads us to the ultimate conclusion from this source material. We often see leaping as this primitive or kind of weird way of moving, but that's just wrong. It's an unbelievably advanced, specialized, and hyper-efficient solution to the unique challenges of surviving in one of the toughest environments on Earth.
In a world that's grappling with climate change, resource scarcity, and the desperate need for more efficiency, the kangaroo offers this powerful model. It's a masterclass in low-energy transport, radical adaptation, and relying on intelligent design instead of just brute force. It's a blueprint for how to thrive when things get tough.
And maybe that's the final message here. The kangaroo teaches us that survival isn't always about taking small, safe, incremental steps. Sometimes, solving the really hard problems means you have to fundamentally change your entire operating system. Sometimes, you just have to leap.